Hello, everyone. I hope you can hear my voice clearly. Can you hear my voice?
Yes.
Dr. Noha? Okay, thanks. Thanks. Welcome all. I'm glad to see you again. Okay, great. Great. You can see me and hear me. Hi, all. Today, we have a little bit different session. I see it's my first time to hear about it, and I hope you will enjoy it. Our session today is about digital twins, bridging the gap between physical and virtual worlds. It was presented by engineer Hesham Gamal Gaafar. Dr. Noha, can you? Sure. Thanks. Today's session will moderate by Dr. Noha. She is the training and events coordinator. And me, Safinaz Mubarak, Northern African coordinator. And for our speaker, engineer Hesham Gamal Gaafar. Dr. Noha, can you skip this?
Okay, thank you, Safinaz.
No, sorry,
thank
sorry.
you all.
I will give a brief about engineer Hesham and then you...
Okay, no problem. Okay.
Engineer Hesham, he is a digital engineering manager at Leeds. He has a master's degree in civil engineering focusing on digital transformation solutions, certified BIM professional by the British Research Establishment. He also listed as a geospatial star by Geospatial World during this year, 2023. And first of all, we will start with a brief about our community, and we will have a full of briefing about the community after finishing the presentation with Engineer Hesham. Dr. Noha, please give us a short brief about the community.
Okay, thank you, Safinaz. And thank you all for your attendance today. Thanks to Engineer Hesham for accepting our invitation. Actually, we are honored for joining us tonight. So this is a brief about our community, African Women in GIS. We are a community made up of African women around the world who work, study, or are enthusiastic about the geospatial industry and its related fields. The community aims through our activities to allow its members to be themselves, create networks, gain mentors, get career advice, partake in geo projects to improve their portfolios, access the job opportunity as well as geo course informations, and showcase their work to the world. So this is a one slide introduction. For further information about the community, please stay to the end of the session. I will present an introduction about the community, our visions, and our activities. We will share now the link of the social media platforms and to join the community in the chat box. Also, the registration link for the participation certificate will be shared in the chat box. You can drop your questions and comments to Engineer Hesham in the chat box when he starts his presentation. So back to Safinaz.
Okay, thanks, Dr. Noha. As Dr. Noha said, please send your question and any information you want to the chat box, and we will answer it. Now, let's, Dr. Hesham, Engineer Hesham, sorry. Engineer Hesham, can you hear me?
Hello, yes, I can hear you.
Okay, I'm really glad to have you today.
Thank you.
Okay.
Shall we start?
Yeah, sure. The floor is
Yeah.
yours. You can start.
Great.
Dr. Noha, can you stop sharing?
Mhm. Okay. Can you see my screen?
Yes, your screen is clear and your voice also.
Okay. Thank you, Engineer Safinaz and Dr. Noha. I'm glad to be here today for the second time with the community with African women in GIS. I am a big fan of what the community is achieving and how it focuses on empowering the woman in the GIS community in Africa, and I like what you're trying to do to help and to empower the woman through their careers, and of course focusing on helping them to make their challenges easier. Thank you, everyone. Thank you for attending the session tonight. I think it's tonight for most of us, especially that we're making it in the night and in the weekend. So I appreciate your time and effort, and I hope you like the session and you find it useful. First of all, I will start with a question for you. What do you expect from this session, so you can feel like it's beneficial and handy for you? I will wait your answers in the chat box. What do you expect from the session to be beneficial? Why do you decided to attend the session tonight? What is the question that is in your mind that you're trying to answer and you thought this session might help you to answer? Mhm. Okay, I assumed three questions, and the traditional three questions: why, what, and how. And of course, I'm going to try to give like some insights about your expectations about understanding how digital twin works and how it is related to the geospatial technologies and the GIS. Also, we will give a little hint about the GIS and AI and how they are related. Of course, we're going to talk a lot about the relation between the GIS, the geospatial data, and how they can help building digital twin systems. And yeah, thank you for your participation. We will try today to answer your questions, and of course after the session we can talk and you can reach out to discuss further details. The digital twin topic is kind of trending now, and it's a hot topic when it comes to managing the physical assets, as you see in the title of the lecture, bridging the gap between the physical and the virtual worlds. So to answer your questions, we're going to go through the traditional workflow, why, what, and how. And I know that usually we start with what, then we go to why, then we end up with how. But today we're going to focus on the concepts. It's not going to be a practical session. It's going to be a conceptual session to understand what's digital twin and what is its component, its capabilities, how it can help us in facing the current world its challenges. And you, after this, after understanding and digesting the concepts, you can decide which part you're going to go deeply to learn more about its technical details and how you're going to implement it practically. So today, as we will discuss, we will see that the digital twin is not just one man job. It's multidisciplinary. It needs a lot of people with multiple skills to build a digital twin system, as we will discuss in seconds. Okay, thanks, Samad, for your questions. Okay, starting with why. Of course, I'm sure that most of you, or maybe all of us, have heard about the terminology digital transformation and some other words that are similar to the digital transformation, like digitization or digitalization. And we can consider all of them as stages to achieve that digital transformation. So at the start, the digitization is focusing on converting or transforming the records that we have from the paperwork into a digital form. For example, like what we're doing when we have a paper map and we're going to digitize it to make it in a digital form to be used as a digital map and to do our spatial analysis and all of this kind of computer processing. The digitization is focusing on two things. The first thing is converting the information from the paperwork or the paper-based form to a digital form. Then we need to organize all of these information that now it's digital, and now we're ready to organize them. That's why we use the relations between the feature classes, the relational databases, and that's how we are ready to go to the next stage in the digital transformation journey, which is the digitalization. The digitalization is focusing more on the process. Now we have the information and the data in digital format, and now we are focusing on using them. So we're going to focus on the process to automate some repetitive process. We don't need our smart engineers and our smart humans to waste their time and effort in doing simple tasks and the repetitive tasks that the machine can do for them. So we're going to make our smart humans to focus on the complex processes or complex problems that need their education, high level of education, and their skills, and we're going to leave the repetitive tasks for the machine. Then we're going to, now we have an automated processes, we're going to make it streamlined, like we don't need the client or ourselves to go through a lot of steps to do just one task. it might be not repetitive, but it might be a lot of steps. So we need, after automating them, to optimize them or to streamline them to make it easier for us. And now we're ready to the final stage, which is the digital transformation, and it focuses on the deep or a series of deep coordinated culture, workforce, and technology. It focuses on the people themselves and the organization themselves, how they are ready to use what we were preparing in the digitization and the digitalization. So it's about the mindset itself. So now we have the data, the systems, the processes, and the people are ready to use them. That's how we are going from the paper-based work, the manual work, to the digital transformation. But of course, we've heard about the how the digital transformation is effective for most of the organizations, but not all organizations or not all sectors or industries can be satisfied with just the digital transformation, the traditional digital transformation. Why? Now we can imagine a supermarket. The supermarket contains a lot of products. So to achieve the digital transformation for this supermarket, we will have like a database. The database will represent every item in the store as a record that contains all of its information, dates like receiving date or the expiring date, the prices, the amounts, and whatsoever. But in case of industry like oil and gas, architecture, engineering, mechanical, manufacturing, construction, all of these kind of industries, it's kind of more complicated because it focuses on not just a record, it focuses on the relation between the components itself. We need to understand the component between the car body and it's the motor. We need to understand the relation between the gas pipeline and the pump station, or sorry, the water pipeline and the pump station, or the manhole and the gas pipeline, or the column and the slab, the door and the wall. All of these kind of relations we cannot understand. The traditional databases or the traditional tables cannot help us to understand what's happening in the real world. So if you're checking a traditional table that contains all the information about some building, it will not help you to understand how this building is in the real world. If there is something happens wrong with an oil pipeline, you cannot, the traditional databases or the traditional tables will not help you to understand what's happening in the real world. So here the traditional databases will not be very effective in this case. So we need more sophisticated solution. We need more dedicated solution for such industries. We need something that can help us to for better understanding of the real world asset or the physical assets. And that's to understand this, we will go for a story. I have a story. It's not a bedtime story. I hope you still focus with me after this story. The story is about the Apollo 13. It's a journey to the space that was back in 1970, and you can imagine that back in 1970 the technology was not that advanced like what we have today. But what happened that maybe some of you have seen the movie Apollo 13. It was in the cinemas, I think it back in 1950, starring Tom Hanks. Anyway, the idea of Apollo 13, that it faced like an issue that made the ship cannot move and stuck in the space. So a lot of people that were in the ship were in danger. And here comes the first application as claimed for the digital twin. NASA had an exact or a digital copy of the ship, and then they have like sensors in the ship itself, and they can from the Earth, they can notice all of the what is happening in the real world asset, which is the ship in this case. So they now have a better understanding of the situation. They use their digital model or the digital copy they have on their computers and on the Earth, and they did some analysis, simulations. They have tried some different solutions to see what is the best solution for this situation. And after experimenting some different scenarios, and after some data analysis, they decided to go for the right decision. And that's how Apollo 13 that like returned to the Earth safely. So can you imagine this situation without having a digital twin, without having a digital copy of the ship in our computers? I think the situation will be a lot bad. That's the benefit of that digital twin. The digital twin, and back then in 1970, there was no there is no terminology like digital twin. It was just a stack of technology that we are using to help us to make a better decision depending on a better understanding for the real world assets. So that's why we need a digital twin. That traditional databases cannot help us in a lot of industries that focus on a real physical asset. Then that's why we decided to we need a better understanding, a better tool to for us. So we moved to some technologies that ended up with the terminology now, a digital twin. So what is a digital twin? From the story of Apollo 13, we can have a simple understanding of what's a digital twin. Digital twin is a digital representation for the real world asset that focus on the connection or the communication between the physical asset and the digital model. So the connection will be we have a design in the digital model, so we will implement this design in the real world asset. Then when we have the real world asset, we need the digital model to be a copy of the real world asset. And how we can do this with by updating the digital model with every change that happens in the real in the physical asset. So if there is something that it changed or something that happened in the real world or the real world asset, it should be updated in the digital model. And to have what we call a digital twin, we need this to be in real time. And here comes the usage of the IoT or the Internet of Things. The Internet of Things is about connecting every asset or every element we need to monitor with a sensor. So Of course, we won't add a sensor for everything, but we will add sensors for the type of feed we are focusing on. For example, if you are monitoring something like the flow inside a water pipeline, so we need to add a sensor for that, and whenever the flow decrease, that means there is a problem. That might be a crack or a leakage at some point. So it will help us to make a better decision and in the right time, because we can have this update using like something like mobile device, or some site visitor will go to the site and update the model, but the IoT sensors will help us to have this information once it happened in the real world. We will have it in the digital model. That's how we can build our digital twin. Also, the digital twin can have a two-way communication. So we, in some digital twins or digital twin systems, you can also, like, you're updating the digital model from the real world by the real world feed. You also can control the real world element from the digital twin. So like if you have this leakage scenario, you can decide to, for example, close a gate or close a manhole in the real world asset using your digital model. That's how the digital twin works. So by understanding this, what is digital twin and why do we the digital twin and how it helped us to reach an advanced way for the digital transformation. Now we need to discuss the digital twin levels. We've mentioned minutes ago that we don't have to add a sensor for everything that is happening in the real world. We might just need a sensor for the temperature, the heat, maybe the water flow, like the example we said, something like maybe the deflection that happens in the slabs in the buildings, something like pollution in the air or in the water. All of this kind of sensors, we don't need all of these sensors to have, but we were going to define the type of sensor depending on the feed we're trying to monitor. Here comes another question. Do we need a digital twin for each physical asset we have? The answer is no. That's why we have different levels for the digital twin. It depends on the business case. It depends on what you need. So the digital twin, the complete digital twin, as we described, with mirroring the world in real time, it's not mandatory in all cases. And let us describe the digital twin levels, and we can imagine what's the difference between them and what's the cases where we need a digital model or digital shadow or digital twin. The digital model, or we can call it the first, the digital twin level 1 or level 0, or the first level of the digital twin. It depends on creating a digital model for the real world asset, but there is no real-time communication. There is no real-time updating. So we have, for example, I believe that most of the attendees are either BIM or GIS professionals. So if we have like a CAD drawing or a GIS map or a BIM model for a building or a bridge or whatever, and we don't have sensors, or we don't have a site visitor that can collect some information using mobile device or some paper-based forms to update the digital model. That's the digital model. We have a digital copy, but it is not well communicated with the real world asset. So it's not a real copy. Yeah, it represents the real world asset, but it does not have updates that make it identical to the real world asset. That's the digital model. If this digital model is connected to the real world asset, we can update them using mobile device, digital forms, or even collecting the information using paper-based forms and then updating them using the computer back in the office. Now we have a digital shadow because we have an updated model, but not in real time. That's how we have a digital shadow. The digital shadow is an updated model for the physical object, but not in real time. Then we have the digital twin. The digital twin have a real-time communication between the real world and the real world object and the digital object, and it can be two ways communication. So you can the physical world asset can send the feed to the model to update it, and the digital model or the digital twin, you can control it, and whatever you do to the digital model, it will update the real world asset. There is also, as claimed in Tesla, that whenever there is a software issue that happened in the car, every Tesla car with every driver, it has its digital twin in the factory. So whenever it has some software issue, the factory will solve it whenever the issue happens. That's how it happens. That's how it fast, and that's how it's effective. So now we understand the need for the digital twin and how it can help us to make the better decision in an optimized time. And now we understand the different levels of digital twin that we can decide which type, which level of digital twin we need in our case. Now we have this workflow that was made by the Digital Twin Consortium, and it's an organization that focuses on the digital twin processes and the digital twin systems, and it's like the ISO. It's trying to make standards, industry standards for all the digital twin definitions and processes. So the idea of the digital twin is about the industries that are dealing with real world assets and complicated assets like cars, buildings, bridges, pipelines, networks, and all of this kind of stuff. So the digital twin process, it describes the process as how you communicate the information between or through the different stages of the product life cycle, and this communication to be well communicated, so there is no loss in the information, starting with planning. So that when you plan to build a new city, a new building on a new product, and you have some information and you need it to be well communicated to the design phase, then you need it to be well communicated to the construction phase. So the construction itself, like in the construction industry, you need it to be as close as the design, and then whenever some changes happen in the construction phase, it must be reflected to the model. So when you finish the process of the construction, you have an updated model that is matches with the real world element. Then the commissioning or the handover of after the completion of the construction, then it comes the longest period of the life cycle of the product, which is the operation. The operation, or like we can call the facility management, the asset management, all of these terminologies happens in this stage. And what we and what we're doing through all the past stages to be ready for this stage. This is why all of these stages happens for the product when it's in use, when we are using the building, the utility, the product, the car, or whatever. And in this operation phase, maybe we need some maintenance. So we need the building also for the digital twin for the maintenance. Something like the IoT sensors that we talked about. It helps us to do a better operation and to tell us if this element needs a maintenance. And of course, if we need to retire or demolish the building, if we're going to demolish some building, we cannot just go there and demolish the building. It needs calculations and simulations, so we can demolish the building without affecting the surroundings, whatever, if the surroundings are other buildings or the environment itself. So that's what we are talking about, the digital twin as a process, how the information will be well communicated with the least amount of information loss. We're trying to make the information loss is zero through the life cycle of the product, and whatever the product is, from the planning, design, implementation, and handover, and the longest period of the life cycle, the product life cycle, which is the operation, including the maintenance, and if at some time we decided to retire or to demolish this product. And we can see here after every stage, we have the as planned model, the as planned designed, and the as constructed. And if we have here, of course, I'm sure that most of us, all of us, either CAD professional, GIS professional, or BIM professional, who have heard about the as-built model. The as-built model is the building as it is, the building as it is in the real world. So you can have a real mirror for the real world entity. And here, if we can have a look here, we can see that the GIS, CAD, and BIM are mentioned here. Why it's mentioned here? Because we need, in addition to the traditional databases, we need the visual models, and it's not about visualization, and I'm sure that you understand that. The GIS or the BIM or the CAD, it's not about the visualization, it's about having the information in a visualized way, so you can understand the relations between the real world. So you can understand that this street cannot be intersected with this street, this building cannot be intersected with this building, and so on. Also, the other visualization technologies like augmented reality. The augmented reality is focusing on generating the digital model in the real world. So it's like when you go for some inspection in the site, and you need to compare the design to what is implemented in the site. So you can put like some glasses or a headset that will visualize to you the design, the graphical design or the digital model, and you will have this digital model in the real world. So you can imagine or you can compare between the design and the what is implemented. The difference between the augmented reality and the virtual reality, that the virtual reality is creating a full environment that is generated by computers. So it's not like having the digital model in the real world, imagining the digital model in the real world and comparing between the digital model and the real world asset. No, you will be like in the game. It's like you're the player in the game. So everything around you is a computer generated. That's the difference, the main difference between them. So that's what is the digital twin. The digital twin it's a synchronized digital copy or digital mirror for the real world, and we have three levels: digital shadow, digital model, digital shadow, and digital twin. And it focuses on the communication of the communication of the information through the project or the product lifecycle. Then we're going to the next stage, which is how to implement a digital twin system. What I'm trying to do in this lecture is making the digital twin system more easy to implement, and that's not the case for all the technology professionals, but it is easier for the JS professionals, the BIM professionals, the CAD professionals, because they are already creating a digital model, as we mentioned in the digital twin levels. So if we're looking in the digital twin tiers, we're going to start from the bottom, which is the digital model. That's the start. We have a digital model that was made in the planning phase or the design phase, and it will be updated to be as built in the real world, and then everything can happen after that. So if you are creating a CAD drawing, a GIS map, a BIM model, you are a lot closer to building a digital twin system than any other technology professional, because you have the digital model, or you can create the digital model. And as you see that we mentioned a lot of terminologies and a lot of technology names. You cannot be professional in all of these technologies, but you can be a professional in what you are doing. But you need to be aware, not just in the digital twin and all of other technologies. You need to be aware of the other technologies, so you can build a better solution, and you can decide what is the other technology that will help you to build a better solution. It's about solution engineering. It is not about knowing everything, because if you've decided to be a digital twin professional, of course you can, but the challenge is if you decided to learn everything about digital twin, about GIS, about BIM, about cloud computing, you cannot learn all of these information, all of these technologies. You can, of course, you can understand most of them. So you can make like a mix and match to build a better solution, but you cannot, and that's my point of view, you cannot be a professional in all of these technologies. So back to the slide, we have a digital model. The digital model can help us to make simulations, like the case of Apollo 13. Different simulations might be like if you have a high-rise building, and you need to test the lateral loads or the earthquake loads, the wind loads, all of these types of simulations, maybe the flood simulation, the crowd simulation, all of these kind of simulation that will cost a fortune if we decided to test these scenarios in the real world. Of course, it will be a lot more cost effective if we're doing these scenarios or these simulations on the digital model. Also, we need the data acquisition tier. The data acquisition is how we update our digital model. Maybe if we're having a digital shadow, we can build, we can collect the information using the mobile device or in a manual way. But if we're trying to build a complete digital twin, we need IoT sensors so we can have a real-time communication with the real-world assets. If we have the digital model and the updated information from the site and the physical element, we can do our analysis and processing. Maybe we can add to this tier, to the analysis and the processing, we can add the machine learning algorithms so we can make a better decision. There is here in this tier, we can, here comes the use of the artificial intelligence. So the algorithm can predict when this specific element needs to be maintained. When will this element will be maintained? That's how the analysis and processing, and in this tier we can add the predictive maintenance algorithms, or some references called cognitive digital twin. Cognitive digital twin, that a digital twin, a synchronized digital twin that contains machine learning and deep learning algorithms that help to do more analytical and processing to make a better and optimized decisions. And of course, the visualization, because we are dealing with complex structures and the complex industries, and we need to understand the relation between the elements in the real world. And in this layer, we can add something like the business intelligence or the dashboards. We can also add the digital maps. As we can see here, that the digital twin is not just about just the GIS, but the GIS is a very crucial and critical layer in the stack of the technologies that build a digital twin in most of the industries. Maybe some industries like medical, if they are creating a digital twin for a human body, they do not need a GIS map. But in most of the cases, like agriculture, construction, oil and gas, roads, utilities, all of these kind of industries needs the GIS in their technology stack. If we have a look at this graph, we can see that it is kind of similar. It shares the same idea with the digital twin process that we have discussed. So it's a lot similar. It focuses on increasing the level of information, the documentation, the non-graphical information, the graphical model, the level of details. And I'm sure that you're familiar with the terminology. Level of details is increasing with every stage we're going through the project, during the project, starting with the brief or the planning, the concept and the design and definition. All of these terminologies are different levels of design. Then the building or the construction, the handover and the commissioning, then the operation or the in-use and the longest period in the project life cycle. What's the difference between this graph and the other graph? This graph is a lot older than the digital twin graph. This graph is how ISO 19650 describes the BIM process or the building information modeling process. So there's a lot of similarities between the digital twin and the BIM, because the BIM is focusing on the communication of the information between the project stakeholders through the project stages, and how the level of information is increasing when we move from a stage to stage. That's what we call a common data environment process, or the BIM process, the building information management or building information modeling process. So we can call the digital twin is industry agnostic. So the digital twin is not dedicated to a certain industry. It's for all industries, including medical, construction, and maybe other industries that needs monitoring and operation for real world assets. But it's not just about construction. The BIM, we can call it, maybe we can call it a digital twin for construction. So the BIM, or the building information modeling, is doing what is trying to do what the digital twin is trying to do for all the other industries. But if we're focusing here on the graph, we cannot see anything about the IoT or the cloud computing or the virtual reality, or for using all of these emerging technologies that help us to have a better understanding of the real world assets. And in addition to this, and the most important thing for us today as a GIS professionals, that there is no location information. How can we manage a city with all of the buildings, the utilities, the underground utilities, including the energy utilities, the wet utilities, and all of these types of complicated structures without having the location information. Can you imagine having the leakage scenario or a crack in a pipeline in a city without having a GIS system? Even if you have the building information model that contains the relation between the structure elements, the elements of the structure, but you cannot know, the BIM provides you with the power to understand the relation between the elements and each other, but you cannot know where is these elements in the real world coordinates. Here comes the importance of the GIS. In this graph, we describe the BIM or the building information modeling as a process, but the BIM also have another dimension, which is the BIM as a technology. The BIM as a technology help us to do a lot of things, and the power of the BIM usually in the design phase with preparing the design to be ready for the construction phase. So you need to be to make sure that everything in its right place and the loads are right. So whenever you use the building, it's not will be in danger because of the load, with whatever the load is, the live load, the dead load, and all of these types of things that engineers and designers need to focus on. So the BIM empower us with this clash detection, and the clash detection is similar to what we have in the GIS with the name topology rules. It focuses on the relations between elements and each other, and for example, there is no engineer can draw a door in a slab. The door and the window must be in a wall. So this clash detection, that's a very it's an oversimplification, but it describes how the BIM works. For example, if we have an air conditioning duct, it cannot go through a beam, a structural beam. It will cause a lot of damage if that happens, and other kind of stuff like this. The pipeline cannot intersect with another pipeline. All of this kind of clash detection, it's like a validation rules, like topology rules in the GIS. The collaboration, which is having a centralized model between that contains the structural design, the mechanical design, the architectural design, all in one place, because you know that the building contains multiple designs, and some of these designs can make some conflicts with the other design. So I need to make sure that we have a centralized design, a centralized model that contains all of these designs in one model, like a simulation for what will happen in the real world when it will be implemented. A cost estimation, because it's not just about a visualized model or a 3D model. The BIM is about having an information, a tabular information, just like the GIS. It contains the model and its information, so you can have the cost information and you can have the quantitative and the cost estimation. Of course, adding to this the time dimension, you can have the scheduling for constructing these elements, and of course the visualization and 3D. And I mentioned the visualization at the end because the BIM, similar to the GIS, it's not about visualization. It's about having all of this information in a right way, well communicated, and well visualized. Okay, we have the digital twin and how it is, and how the BIM help us to implement this digital twin process in this complex industries. But we've mentioned that the BIM misses an important information, which is the GIS or the location. So of course, you've heard about the integration between BIM and GIS, or the GeoBIM terminology, and how it's very, very tangled with the digital twin. Because if you need to build a city and to manage a city, to operate a city with with massive and tons of information and elements, you cannot do that with just BIM. And if you try to make it to implement this using GIS, you will miss a lot of details that are in the BIM. So we need a combination between the information and the functions that BIM provides, and between the information and the functions that the GIS provides. Having these two main players, we will have an aggregated model that contains the outdoor and the indoor information, well communicated, starting from the planning, design, construction, and ending with the operation. We will have a city information model that can help us to integrate with other technologies like Internet of Things, to have a better understanding of the real world asset, and to have a better operation for the real world asset. And that's how we can build a digital twin system using what we already know in the GIS, integrating with other technologies and other data formats. In the GIS, you can have a lot of formats, from the remote sensing sensors, satellite images, LiDAR, BIM, and CAD information. And you have all of this information in the container of the GIS. So you have a very strong model that is ready to be integrated with other technologies. And that is already happening even before we have the new terminology, a digital twin. And this way we can have a smart city and our smart city management. I cannot imagine that we were trying to build a smart city and to make like a CIM or a city information management or city information model without having this integration between BIM and GIS, integrating with other technologies, starting with IoT, and of course, in more advanced version of the digital twin, utilizing the power of machine learning and artificial intelligence. And I think that's it for today. I will be happy to receive your questions if you have some questions now. Also, you can find me on each social media platform with the name Hesham Gamal Gaafar, or you can scan this QR code to find my LinkedIn account. Also, you can visit my website, digitwin.pro or digitwin pro. In this website, I'm trying to collect my scattered online content like articles, videos, or and these types of content that is dedicated to the digital twin and the digital twin in technologies stack like GIS and BIM in just one place, including the recording of the lecture today when it's out on the YouTube. Okay, I'm ready to receive some questions. I think okay, creating and okay, I will start with the question of Mr. Ahmed. What are the main challenges or limitations associated with creating and maintaining accurate digital twins? Thank you for your question, Mr. Ahmed. The current challenges are about the how can we create a digital copy for a real world element that is already there. That's a hot topic now. How we can create a digital twin for already built structure. It's not a new structure that we have already the drawings and the planning, and we can go through all of this process. What if we have a building that is already there, something like a museum or an old house or whatever, like something like a historical place. And here comes the role of reality capture and scanning. That's one of the challenges that face us today to create an accurate digital twin. Another challenge, it's not about creating an accurate digital twin, but it's about digital twin systems in general. That to have a complete digital twin system, you need a lot of skills to build just one system. So it needs, of course, a lot of it needs high cost. For now, I believe that every technology starts with high cost, then it will be have an optimized cost and a lot of high educated professionals. What will do artificial intelligence? Yeah, I think we have mentioned this about the predictive maintenance. Also, how do digital twins facilitate, collaborate, and acknowledge sharing across different stakeholders in an organization? There is a lot of systems that needs to do this collaboration for digital twins. There is a lot of tools. Microsoft have some tools, Esri have some tools, Autodesk have some tools, and we can have a mix of these tools in one framework. It depends on the solution itself. Another question from, thank you, Brian. Another question from Zainab. Google Map example of a digital twin. Yes, we can consider a Google Map as a digital twin because it's a synchronized map for the real world vehicles. Yes, I think we can consider Google Maps as a digital twin. Can please more detail about water quality monitoring system using project report or any links for this project. Okay, thank you, Fatin. Please reach out to me through LinkedIn, and I can send you an article or a paper about this topic. Thank you, Ahmed. Thank you, everyone. Please, if you have further questions, please reach out. Also, if some of you needs to or can share some thoughts about the lecture, can have something like a learning journal, online learning journal in a LinkedIn post, just share it with me and we can have a discussion about it. Thanks, everyone. Thanks, Engineer Safinaz and Dr. Noah for your invitation today. I have enjoyed the night. And I hope we can meet in other lectures.
Okay, thanks, Engineer Hesham. We really enjoyed this session today and hope to see you again and again. I'm sure it will not the last time to see you with us.
Yeah, I'm sure. Yeah.
Yeah. Okay, and thank you all. Thank you for attending today. I hope you enjoyed and learned a lot about digital twins. And as Engineer Hesham said, please, if you have any question, any suggestion, reach out to him. Or if you need anything from our side, please reach me or reach to Dr. Noha. Also, you can send your question to the chat box before ending this session. Okay, we can continue with Dr. Noha about the community in case if anyone will send a question.
Okay, Safinaz. Thank you, Doctor. Thanks, Engineer Hesham, for sharing your knowledge with us and actually your insightful and informative presentation. Thank you so much. I will share now. Could you please stop sharing?
Yeah, sure.
Okay. Okay, I will share now the story map of the community. So, okay, at the first of the session, I present to you a quick introduction about who we are, and now I will continue to presenting about the community. First, our mission and our vision. What do we stand for? Okay, our mission is to create a safe space for African women in the geospatial industry, irrespective of their career level. And our vision focus on bridge the gender gap in the African geospatial industry. This is 4 colors are indicated to our identity. The leafy green is our is indicated to our love for nature and geo. Pitch black for unity and support among members. Light gray for gender equality, and pure white for safety and safe space. How we start our community. First, in July 2017, Chidema created her community, Women in GIS in Nigeria. Then in April 2019, Sayana created the community Women in GIS in Ghana. Then in June 2019, Chidema and Sayana met on LinkedIn and discussed reasons for creating their communities. And in October 2019, they merged their communities to African Women in GIS. In January 2020, the African Women in GIS community was made public on social media. Now our community is growing with about more than 500 members. Okay. Residing in more than 30 countries. As of May 2022, we have members residing in Nigeria, Kenya, Ghana, Egypt, and South Africa. Due to our growth now, we have currently about 28 volunteers who help run our organization. We have now more than 9,000 followers in social media platforms. This map indicates or refers to the locations of our members' maps in the world. So why our existence, or what the problems that influenced our existence? First is male-dominated geo industry, lack of female role models and career guidance, inaccessible GIS job information, also inaccessible and unaffordable GIS events and courses. Lack of GIS potential awareness and lack of grassroots awareness. Okay, let's escape the problem. So how are we contributing to solving these challenges? So our contributions throughout our activities to solve these challenges are networking, learning, mentorship, and awareness. This is a brief about community activities. Actually, the membership is restricted only for women, but all of our events and webinar and other activities are public. This is some example of our events like International Women's Day in 2020. Our community also was invited to join a special panel of Women in GIS groups to share our stories during 2020 in SVUC. Each year, our community joins a homecoming event organized by North Star and Flags in GIS. We have also internal events that we organize for our members, and the member speaker panel events. Also, we have some collaborations with active with organization related to and communities related to GIS or geospatial industry. This section in our site about speaker consultation and the career exposure. You can meet our public member section that allow members to be contacted for speaking, consulting, and any other geo-related opportunity. And this section in our website about is a blog. You can find the articles written by our members about GIS related fields. Now you can follow us in YouTube to watch our recording of our events and the training programs. I sent the link of the social media platforms in the chat box. You can check it. Also, the recording of this session will be uploaded to the YouTube channel. We made some physical meetups, and now we are planning for a meeting in Cairo for North Africa members. Now we are growing. We have the GIS mentorship program. This is some numbers about the mentorship highlights. And this map also you can show the location of our mentors locations. So our community has created a platform which is a source of motivation for African women to take up career path in GIS. We aim to expand in the coming years, support more African women in GIS industry, introduce the young generation to GIS careers, and help Africa benefit from the application of GIS and its related fields, as well as fundamentally bridging the gender gap in the African geospatial industry. Also, we are open to fellow African women in Africa or the diaspora who wish to join our Slack and WhatsApp groups. Please follow us on LinkedIn and Twitter and view our website. The link is, as I mentioned, in the chat box. And thank you all for your attendance today. Thank you, Safinaz.
Okay, we came to the end of our session today. I hope you enjoyed and learned about the topic. Thanks, Engineer Hesham. Thanks all for joining us. Thanks, Dr. Noha.
Thank you, Safinaz. Thank you
all.
I
sent the certificate link to the chat box. Also, the community profile on social media. You can follow us. Also, I sent Hesham LinkedIn profile. You can connect with him if you have any question. Okay, thanks all. And I wish you a good night. Hope to see you again. Bye-bye.
Good night.